Okay, so the first step in this problem is to write down what we know and then also what we're trying to get to. So I highlighted the question in red so that I could see what I know and what I'm trying to report my answer in. So I know that he's trying to remove 12 pounds of fat, so I go ahead and write that here. And I'm trying to figure out what that is in 2-liter soda bottles, so I write that there. And then my next step is to figure out what path I'm going to need to take to get from pounds to 2-liter soda bottles. So I start by writing what I know, so pounds, and then I go up to the problem and I look for a conversion factor that has pounds in it. And then I see this one, it's 1 pound equals 0.454 kilograms. So I write that next as my next step. Then whatever the next part of this path is going to have a conversion factor with kilograms in it. So I go and look, and I don't see one, but I do see one that has grams per milliliter. So I go ahead and write that here, and then I think to myself, what do I need to do to get from kilograms to this other one I know, which is grams per milliliter? And I remember that I know a unit conversion from grams to kilograms, so then I write that here as my third step. I'm at grams per milliliter, and I need to get to liters still, and I go up and I don't see any more conversion factors, but I know that if I have milliliters, that I can do a unit conversion, milliliters to liters, and that will get me to my final answer, liters. So then I start filling in my dimensional analysis table, and I make sure that I use the actual numbers from the problem, but I follow this path that I've already laid out. So I write down what I've given first in the top corner, which is this 12 pounds, and then I follow this path, which the next part is pounds per kilogram, and I make sure that whatever unit is here is also diagonal from it. So I know that my pounds is going to go on bottom, and up here it says it's 1 pound per 0.454 kilograms, so I fill that in, and then this unit has to be the same as this unit, so my next step is grams to kilograms, so I write that conversion, and then this unit has to equal this unit, and I know my next part is grams per milliliter, so I go up into the problem and I find this conversion, and I go ahead and put that in, and I know mils is here, so mils will also need to be diagonal, and I know this unit conversion, so I can fill that in. And then I'm trying to get it into 2-liter soda bottles, so that means there's 2 liters per 1 2-liter soda bottle. So because this is liters, this also has to be liters. And so I'll say that there's 2 liters in 1 2-liter soda bottle. And then I'm going to check my units and then calculate my answer. So check my units just to make sure they cancel. So pounds, pounds, kilograms, kilograms, grams, grams, mils, mils, liters, liters, and I'm left with 2-liter bottle, which is what I was trying to get to all along. So then I calculate. When I type this in my calculator, everything that's on the top of my dimensional analysis goes on the top of my fraction bar, and everything on bottom goes below it. So I type all of this in, and this is what I get. And she asks us to round to 2 decimal places. And so what I'm getting is actually 2.90. But if you round it a little differently, you might get 2.89. So, and that's because the 7 rounds that up to a 9 here and then a 0 in that place. So depending on how you rounded, this is your final answer.